Afternoon, everybody. Hopefully the digestion is going well. I'm talking about a bit with this project. Is a new project started this year. Growing season here. It's called Growing Robust Avocados. Is in collaboration with quite a few people. It's a national project. It's from Hort Innovation, Levy Funds in this case. There are people from us, DPIRD, and then a big team from Queensland that is currently leading the project, and even Central Queensland University for a PhD student. The project in itself has a few aims. That is to increase the quality of an Australian avocado production by supporting industry. Because we're trying to, there are several definitions of what is actually a robust avocado. A robust avocado practically is a fruit that is able to withstand from the moment that it actually is born on the tree up until the plate of the consumer, and makes it actually the consumer wanting to go and buy another one and eat another one and continuously do that. That becomes a robust avocado. You know that there is a ton of things that happen is in the meanwhile to that fruit to make sure, not to make sure, to try to actually avoid that. So naturally, there are a lot of things, so heats and diseases and all of those kind of things make the tendentially the quality of that fruit to try to decline, and that is what this project is all about, is in trying to identify areas of interventions, of making the fruit slightly better to make sure that it gets the quality to the consumer as we want. So it's trying to identify pre- and post-harvest management strategies that would improve the robustness. The focus is on nutrition, moisture, environment, those the crop management. So practically, the thing is, we cannot really control the entire or study the entire way of producing, because that would take probably 20 years and not 3.5 as the project is supposed to be. And what we want to produce during this project are decision aid tools, best practice guidelines, ways of informing growers of moments and actions to be able to improve this robustness. As I said, it's a very spread out project. It's in several locations in Australia. So we have our area where in Western Australia we have Pemberton, Busselton, and Karabuda as locations because of the different climates and environments. Queensland has the most of it. There is North Far Queensland, Central Queensland, mid place as well. So there is several locations in Queensland similar to what we have, and altogether it becomes a national project where we coordinate and do experimental trial sites, where all of the major sites that we have, which is 3 per location, we do have these sites that they receive the same treatment. So we are trying to actually identify a bit of the environmental aspects of it, in trying to actually define what the different environment and climates would do to the robustness and how to manage accordingly. Because a lot of times, what the Queenslanders do, they don't always work here, and vice versa, because of the different climate and the soils. And so all of that, we are trying to identify different management. From previous projects, it came out that how do we do some suggestion, let's say, to improve the avocado fruit quality, which is part of the robustness. And as you can see from here, there is pruning, there is rootstocks, there is mineral nutrition, all of the potassium, nitrogen, organic matter, and then all of the condition in the soil, all of this kind of situation, diseases, they would all affect what actually is the absorption and what actually is how the fruit grows, how the fruit incamerates and absorbs all of the nutrients and all of the components that actually would make that fruit withstand from the starting point, as I said, up until the plate. So in this project specifically, we decided to try to focus mostly on the nitrogen to calcium ratio that a lot of literature has identified that as a sort of an indirect measurement of robustness. because a low, relatively low, let's say below 30 of this ratio in nitrogen to calcium is helping in diseases because it makes practically the skin sturdier, the cells harder, and so therefore they withstand the heat meaning that bouncing and those kind of things, not temperature as well, heat, but still. And then they would withstand, for example, a fungus going in, breaking the skins, and so all of that helps in this robustness. And so we are trying to focus on this nitrogen to calcium ratio, but simply applying more calcium in the soil, it's not really the solution. There are, as we said before in the previous slide, there is a ton of situations why and how this calcium actually gets in and makes it available, and there is uptake, translocation, and a lot of different things. In this project specifically, we have a part of a PhD student from Central Queensland University, and he's going to look a bit one of the major issues that anyway happens in an avocado orchard, which is the variability. Trees are continuously different. The fruit that they get produced in different locations, in top and bottom, and in the side and outside, that they all have an effect a bit on the actual robustness of the single fruit. And so that's why there is a lot of variability within the block. And so they will look a bit into that part. He will be looking at variability in movement of the soil, of the calcium in the soil, because one of the practices of the growers is that of putting a lot of the calcium in gypsum forms and lime forms and all of those things way earlier in the season, because then they need to interact in the soil with the rain, with the moisture and microorganisms, and they start releasing and making the calcium available for the tree. And so they do it like something like 3-4 months before the actual flowering. So at that point, the movement of the calcium in the soil and how long this one stays in the soil is important, and it will be studied under this PhD. So, as we said, calcium, so this we are looking into calcium specifically, national-wise. So how hard can it be? Incredibly. There is so many factors of trying to actually get the calcium in. Specifically, calcium moves through the xylem, and then it is driven into the fruit, into the tree, from the soil, from the roots, because the tree transpires, and the tree transpires a lot when it's growing. It's not only, it transpires always, but I mean, there is a really active transpiration when it is growing. So when the shoots are growing, when the fruits are growing, when there is active growth at different levels, so flowering and the first spring, summerish kind of flash in growth. That is when most of the calcium gets taken in. After that one, the fruit, the xylem in the fruit is compromised and goes in only other stuffs, but not calcium anymore. So whatever you get in that moment, that's it. If you don't get enough at that moment, you're not going to get more calcium into the fruit after that one. So the project in itself, this is, for example, is an image from a drone that the Queenslander, they were actually using to define their orchard. And so to manage this calcium, there are several theories, and one of them is actually that a certain amount of calcium in your soil, if you can guarantee a percentage of exchangeable calcium in the soil, then you are supposed to actually get enough. And this is sort of trying to prove that part, where we actually are going to live as a treatment. We are going to have a normal grower practice, and then we double it. But then at the same time, we need to try to reduce it. And how do you reduce it? We decide to reduce it by applying calcium sulfate, because potassium sulfate, sorry, that should misplace the calcium in the absorption. So the trees should absorb more potassium than the calcium in that case, and so therefore into your fruit reduces the number for the calcium from the nitrogen to calcium ratio. Specifically in Western Australia, we are part of that, as we said, and so we have sites where we are doing the same treatment as I just mentioned, but we have specific local hypothesis, let's say that is still combined, and we look into that specifically, so we actually let the entire country, national-wise, the information to everybody. That is, we're trying to identify a specific moment. So if we are able to couple the growth, the exact moment of growth of the tree when most of the calcium gets in, we roughly know when it is when the major shoot growth is happening. But at the same time, many times you have fruit already in it. There is the new fruit that they want to grow. People want the actual carbohydrate go into the fruit and not into the shoot. But those shoots are fundamental to drive the calcium in. So where is the stop? Where is the moment that you want to, that balance, that threshold where you can start applying growth regulators? So at that point, you stop the tree growth and then you don't lose the carbohydrates and go into the fruit. But you need to have already that fruit in, that calcium in. So then the identification of when the xylem gets compromised. So all of those, we are trying to identify this physiological moment where we can give this information and so an action. To growers that then a measurement, if you are within certain parameters by this time, then you are fine. Otherwise, try to stick something now or you are not getting again. And so that's one of the major aims that we are trying to get here. And in the way how we're doing it, we selected, as I said, the different sites, Karabuda, Basselton, and Pemberton for the climates and location and soils. And we measure a ton of stuff from the trees, so mostly growth, chemical analysis, because we need to identify when and the movement of these chemicals to figure out the timing, as I was saying before, and trying to scan and trying to use as much technology between brackets as possible, for the simple fact that you guys know our state is too big. We cannot actually control all the stuff that happens everywhere as often as we would like, and so we try to do as much electronic measurement as possible. In fact, we are testing this orchard scanning with these guys with this green atlas that again take digital imaging, and hopefully they do the measurements more than us, especially at block levels. And these are a lot of the instrumentation we want to actually, well, we already started to have quite a lot in the field, so we'll do soil moisture up to 80 centimeters, trunk dendrometers to see the general growth of the tree, how the tree in general is growing during the year, and then we have shoot dendrometers to try to identify that particular moment of fast growth in the shoots and trying to identify possibly that threshold. Fruit dendrometers, because that is again the other part, figuring out how much the fruit is growing and see when actually the xylem gets compromised. Different methods of trying to get, if we can find a different, cheaper way for growers to figure out their chemical composition, so through sub-chemical contents. And that is this, which one was it? Yes. This is a new technology that is a fluorescence. It measures dry matter. We did this year, last season actually, a preliminary testing of that, and it came out that it's actually able to predict and detect dry matter in avocado. What was it, the last measurement? Over 92%, 90-something%, so pretty accurate in a dry matter. It's small, as you can see it, compared to of course I did the wrong one, compared to an apple, so it's relatively small, and it's portable, and it's non-destructive, and hopefully substitutes the Felix with a fifth of their cost as well. And so we are looking into that to try to help growers in measures. These are just images of us, actually not us, them, Milan and Declan, working in the field and inserting and setting up all of the different sensors. And in fact, here these are fruit that this was the 80 centimeter sensor moisture, soil moisture, the trunk dendrometer, and then we have the shoot dendrometers and the fruit dendrometers. And so the next step that we are going to do in here is finish to install all of the different equipment, and then and then start counting the harvest and then measuring. We are doing regular leaf and soil and chemical analysis, and altogether we hope to correlate to give an information of thresholds of actions. This is an image, for example, of what actually comes from the digital scanning of the orchards. You have here, that becomes a block. This is actually a Carabuda site. Our staff are in this part of the block where they are older trees, I think. And so but this actually tells it's for the tree height measurement, and it tells the variability within the block and all of those kind of things. So it is already a help in itself in figuring out management-wise what is happening. As you can see here, it is a combination between a camera and LiDAR, and so it gives pretty accurate information and measurements on the trees, on the tree growth, and so we hope that by doing several of them, we are able to really identify what actually is the increase of the volume of the trees to give us a better indication of the amount of pull that they would have on the calcium. Now, I couldn't find, it's funny because it looks pretty dark. This image looks pretty dark. But the camera and the machine is actually able to identify a ton of things. And on my eye here, I can more or less see it, but I'm not sure you can see. In this area over here, you see, there are fruit. And there are small squares around it that they are actually red. I'm not sure that it translates correctly for you guys to see, but trust me, that is what is happening. This thing is actually able to count the fruit. We have to calibrate it correctly, but at this level, it would actually tell you how many fruit you end up having on trees and those kind of things. Yeah, and so a bit of the results, as I said, we don't have much, but mostly because we just started, we are installing everything, and that this season is actually to try to get information on growth and those kind of things. So we have only chemical analysis, and this is from the Carabuda site. Already we have measured 4 times. You have here, there is some red or not. This is because these were the previous season fruits, so when we went to collect the new flowering, there were still old fruit, so we collected that to have an idea what was happening and what we were expecting. And so these are the parts, so calcium related and the nitrogen to calcium ratio as we were thinking, as we're showing. And practically during the year, the exchangeable capacity goes down, and then the calcium goes down, nitrogen relatively stable, but we are expecting to increase because at a certain point, see, this was at harvest time, practically, because that was happening. And as well as the nitrogen to calcium ratio is going down, but then there will happen that nitrogen increase, and so will go up again, because this was what happened last year. This is to say that we really need to measure a lot more to try to figure out what is the correlation between, well, here is the same, it's just in Basselton, so numbers, as you can see, they are roughly the same, slightly different here, but at the end, there were no much difference in the area where it counted, so they were all good fruit anyway. And so what I wanted to say is that we are trying to correlate and figure out what this number here at this stage, so cauliflower stage, there is a theory that says that this number here at cauliflower is able to tell you what that will be. That in California. I'm not sure if actually is really true. So we are trying to figure this part out in all of these measurements. And during the years, hopefully, by summing all of the measurement and the chemicals and all of the chemically, we would be able to identify a correct timing, because maybe this is the time, maybe it's here, maybe it's later, maybe we don't know exactly. Hopefully it's within the still absorption of the fruit time, to make sure that then you can still do a top-up to have the correct nitrogen to calcium ratio at the harvest. And that's it. Thank you.
Thanks, Dario. With the calcium, do you think there is enough calcium in the soils, particularly in WA, but it's just bound to phosphate as a calcium phosphate conglomerate? that's not then available to the trees. So then adding calcium is not actually helping because it's just going to get bound to more phosphate.
Well, if the natural calcium present in the soil is available or not is a different thing. Because as we said before, it doesn't matter if you add more calcium or not. It's the one that the tree is able to absorb through different methods. And so that's why the growers, they actually still putting up quite a lot of calcium through gypsum and other stuffs, because it is needed. It wouldn't be enough, whatever is currently natural in the soil. If it is bound or other ways, I'm not sure, I don't know, because I'm not a soil specialist. But the thing is, we need to actually add calcium to be able to actually have it absorbed.
Well, I guess the reason why I brought it up is because if it is bound as calcium phosphate, based on my little knowledge in this area, then wouldn't it be better to employ stuff like, because I'm a microbiologist, I'm just thinking that if you employ things like AMF that actually are known phosphate solubilizers, if you unbind the phosphate that's then bound to the calcium, wouldn't that unbind the calcium as well?
Possibly.
Make it more available for the tree?
Possibly. It's something I didn't look into, and maybe there could be something for the soil specialist to look into, to try to make more natural calcium available through natural ways. Possibly. I'm not discounting it. Currently, that's the way that people are going, but yeah, could be a good way of doing.
Dario, due to the low mobility of calcium, do you see much variation between calcium on top of the tree versus the bottom of the tree? I'm an apple grower and we quite often see that.
It's again, yes. Variability within an avocado tree and between trees is incredible anyway. But yes, we would expect to see the same for the same reason, which is the amount of growth happening in that part of the canopy because it's stimulated by the sun. That is where all the sun is, at the top and on the outside of the canopy compared to the bottom and the inside. So definitely there is that part, yes.